going to start the class for Friday. Tomorrow's class. This is Thursday, and let's just get started with let's just kind of do a quick recap. There's the two postulates of relativity, which says that all the physics that takes place in one inertial reference frame can be performed in another inertial reference frame, or in other words, the laws of physics don't change depending on reference frame. So the laws of thermodynamics still take place. But if I'm observing this from a different inertial reference frame, as long as I get my coordinate axis system set up and I know how fast it's moving and things like that, or how fast they're moving relative to me, we should get the same answers. That's basically what it's saying. And the other consequence of special relativity, the other postulate is nothing can go faster than the speed of light. Okay? And one of the things, and it's the invariance of the speed of light. And one of the things that we were finding was that Maxwell's equations didn't quite fit into the mechanics, because Maxwell's equations came up with what the speed of light was, and the issue was we've got a problem. And so they worked the mathematics out, and by experiment it has worked out. So we have this thing that happens, that an object that is moving, its clock is to an observer that's watching this thing go by, watching this person or this ship go by, its clock is elongated. The time is dilated. But the proper time belongs to the moving object. Okay, and the proper length belongs to the stationary. So we didn't talk about proper length. So let's go back to our slides real quick. And here, everything starts with the gamma function. All right, everything starts with the gamma function. If you compute the gamma function first, and sometimes you're not given what v is, and having to tease that out of this equation becomes an issue. Okay, but for the most part, it's not bad. And so we looked at this. Notice as we get closer and closer, yes, come on in.
And officially